Swayam Prabha. Digital India. Educated India.
A very good morning, good afternoon and good evening my dear friends. I am Raghunandan Sengupta from the IIT department IIT Kanpur and welcome to this TQM2 lecture 3. And as you know that we have been discussing about the basic backgrounds, I will try to finish within 2 classes or 2 lectures, and hopefully from the fifth one we will start about the concepts of design of experiments, which is the main bulk portion of that. And once you see I did not say these words in the first 2 lectures, but when you see the introductory video you will understand what actually TQM2 is, because I did not want to go into again the nitty gritties of the coverage of the TQM, and once you see the syllabus, see the video lectures for the 3-4 minutes one, which is the introductory one for the TQM2, you will understand. So, considering our discussion which was there in the concept of PDF, PMF, CDF and the corresponding concepts. So, let us see this example. In an example, each question has 4 alternatives or answers of which one is correct. So, if you are reading this problem, you will understand is something to do with Bayes theorem and the concepts of Bayes theorem, which I did discuss. If a student knows the correct alternative, then she is definitely able to identify it, otherwise she picks one of those alternatives at random. Given that a student has identified the correct alternative, what is the conditional probability that she knew it, assuming 70% of the student know the correct alternative, the question under consideration. Now, one thing is absolutely clear from this problem. So, if you know the problem, you answer it correctly, which is the probability 1. And if you do not know the question's answer, obviously you will make a guess, and the probability obviously would be 1 by 4, because there are 4 alternatives. So, this 2 bullet points, which is very intuitive and very simple, is easy to understand. So, with this we will proceed. So, let us define the following events. A1 as the student identifies the correct alternative, B1 student knows the correct alternative, B2 student does not know. So, obviously B1 and B2 would be complementary. Then we know that the probability of that B1, that means 70% no, is 0.7, B2 which is the percentage who do not know is 0.3. Given you know the question and you will answer it at obviously 1, as I said, and given that you do not know the answer and you mark it correctly is 1/4, from which you will have that given the student has identified the correct alternatives, what is the probability that the student knew the answer is given by the Bayes theorem is about 0.9032. Now, we will cover 2 other concepts, very simple one, they would be used later on. The one is the concept of we will say that 2 events are called independent if the intersection of them is a multiplication of the probabilities of A and B. So, correspondingly we can extend it to 3 and more events also, but for the timing we will only stick to the concept of for 2 events. Now, we will go into the concept of distribution. If you remember, we did mention about probability mass function, probability density function, and we were discussing our CDFs and the corresponding overall view, that how less than type greater than type can be used. So, we will consider those in a little bit more details, because you will see later on some few of the distributions would be very important for the design of experiments and hypothesis testing. So, depending what are the outcomes of an experiment, a random variable is used to denote the outcome of the experiment, and we usually denote the random variable using x or y or z, and the corresponding probability distribution or probability mass functions are denoted by small f of x, small f of y, small f of z, and so on and so forth. So, they can be, if you remember, I did mention it in the second class, and the second lecture. So, if the random variable is discrete, you have the probability mass function. If the random variables are continuous, you have the probability distribution functions. So, this what is mentioned the last two bullet points. Discrete means probability mass function, continuous means probability density function. So, under the discrete we would have basically uniform. We will lay more emphasis on few of them, we will come to that. We have uniform, we have binomial, negative binomial, geometric, hypergeometric, Poisson, log distribution. So, these are the few important one. Obviously, there are other, we are not going to discuss them in this course. So, now let us see what is Bernoulli trial. So, each trial has basically, when you are basically rolling a die. Now, this concept of Bernoulli trial is only applicable for the, no, only I will not see the use the word only applicable. We are basically discussing that for two trials. For any outcome, there are two, when you throw a die, toss a coin, they would be, how the throw of the die would be important, I will come to that. When, so, there are two outcomes, positive, negative, plus, minus, yes, no, red, blue, black, white, so on and so forth. So, when you toss the coin, it is head, tail. So, there are two. When now the question would definitely be coming in your mind that when you roll the die, how there are two. So, consider we are only interested in finding out the even and the odd. So, obviously, they would be background concept would be they are complementary, or say for example, we consider the numbers as less than or equal to 4 and greater than 4, or the numbers may be say for example, equal to 1 and not equal to 1. So, when you are rolling the die. So, in this way basically we will have so called two outcomes, and considering that that trial has trial whatever the trial you are doing. So, we will basically consider that as a Bernoulli trial, provided these other concepts are also true. That means, for any trial the outcomes would be as I said, yes, no, black, white, red, blue, good item, bad item, success, failure. So, these are the outcomes. The trials would be independent. It means that if we keep rolling the die, the probability of the first trial would not affect the second, second would not affect the third, and so on and so forth. Neither would be the second being affected by third and all these things. So, we will consider that, and we will also consider the probability of the success or the failure, or if you consider red or blue, or if you consider black or white, they remain the same from trial to trial, and that means they do not affect. So, let us consider a very simple notion. You are playing a game of rolling the die, and your head and your win or loss in the initial stage, and when you first start playing the game is say for example half and half. Now, consider you start winning or you start losing, whatever it is. Then if the probability of you winning or losing in the next trial, depending on what state you are, whether you are in a winning position or a losing position, then if that changes, obviously this concept of Bernoulli trials would not hold true. So, it is basically independent from trial to trial, and it will continue remaining that. Now, before I discuss the uniform discrete distribution, I did mention when I started the Bernoulli trial, it is only two trials. Say for example, if I have 3 trials or 4 trials, obviously they would not be Bernoulli trials, but they can be basically consider that in a very simple way, where some of the concepts or the intuitive feel of Bernoulli trial can be brought into the picture in those cases also. So, coming back to the distribution, so we will consider the uniform discrete distribution. So, that f of x is given by 1 by n, and a and b are the parameters such that a and b along the real line. So, a can be negative, positive, 0, b can be negative, positive, 0, but obviously b would be greater than a. The expected value is given by, and by the way, so this k would be the amount of increment which is happening. Like say for example, you pick up chits, and chits are marked as 1, 2, 3, 4 till 100. So, in that case the k value would be 1. In case say for example, chits are marked as 1, 3, 5, 7, in that case the k value is 2. So, expected value is given, the variance is given. So, example, so I am just discussing a variance and expected value, they would be if at all used in the cases, we will just take these formulas and do our problems accordingly. they would not definitely not be any proofs. So, example mean generating the random numbers 1 to 10, hence it is a uniform discrete between 1 to 10, where the value of a, as I said, is 1, and said means based on the example which I gave, the value of b is 10 and the increments are 1. So, hence his k is 1. So, and obviously n is 10. So, this is a uniform discrete distribution, how it look like, starting from 1 to 20 for this case, and the f of x, which is the PMF, probability mass function, is plotted along the y axis. Now, consider the binomial distribution. So, it basically comes from the binomial distribution, which you know in general mathematics we must have done in class 10 or class 11. So, the f of x is given by NCX p to the power x q to the power n minus x. So, n and p are the parameters, where p is basically between 0 and 1, and n is a number which is an integer, obviously positive integers, because n can be 3, 4, 5, 6, whatever it is. The expected value is given by as written in the formula n into p, variance is given by npq. So, consider you are checking the quality of the product coming out of the shop floor, or product can either pass or fail with probability 0.8 and 0.2, and for checking you take such 50 products. So, n is 50. Then if x is the random variable denoting the number of successes in this 50 inspections, you will basically have 50 cx p to the power x q to the power n minus x, and here n is 50 as we know, and the values of p and q are given as 0.8 and 0.2. So, this is the binomial distribution, just a sample which we have just plotted on Excel and just given it for our own benefit to understand. So, f of x, which is the PMF along the y axis, x values along the x axis, they start from 0 and can go on depending on whatever the n value is. So, very simple. So, we will consider very simple examples. So, question is 20% of BSNL shares are owned by Mr. Muralilal, a random sample of 5 shares is chosen. What is the probability that at most 2 of them would be found to be owned by Muralilal? So, you can basically solve it using the simple binomial distribution, where p value is 0.2, q value is 0.8, and n value is given as 5. So, we want to find out the probability of x being less than equal to 2. So, obviously, the x will take the value of 0, 1, 2, or other ways can you do is that basically 1 minus the complementary of that. So, the probability comes out to be as given in the last line, starting the first term being 5c0, 0.2 to the power 0, 0.8 to the power 5, when obviously the x value is 0 and n minus x is 5, till the third value is given as 5c2, 0.2 to the power 2. So, negative binomial distribution is given by the formula r plus x minus 1, c r minus 1, or c r x, whatever way you are looking at, p to the power r, q to the power x. So, x values basically take from r plus 1 and it continues in infinity. So, p and n are the parameters, expected value is given by r q by p, and variance is given by r q by p square. So, consider example that where you are still inspecting items from the production line, but now you are interested in finding the probability distribution of the number of failures predicting the fixed success getting the right product. Then we will have, considering p is equal to 0.8, q is equal to 0.2, the distribution of x is given as shown in the last line. So, this is the negative binomial distribution with some values. Again we are plotting PMF along the y axis, x basically along the x axis you have the values for x. So, suppose that the probability of manufacturing process producing a defective item is 0.05. Suppose further that the quality of any one item is independent of the quality of any other item produced. So, consider Mr. Rao, the quality control officer, selects the items at random from the production line and stops his inspection when he gets 10 good items. Then what is the probability of getting 2 defective items before he stops production? So, you need to find it. So, given p as 0.95, q as 0.05, hence the required probability is given as when x is equal to 2, and you have those values in front of you. Consider the geometric distribution. So, geometric distribution f of x, which is the PMF, is given by px to the power q. So, p to the power 1 and q to the power x. So, technically it can be considered the case where you get the head or a tail for the first time very simply. P is the parameter and expected value is given by q by p. So, if you remember in the earlier example it was r q by p. So, it is now q by p because r is 1 and variance is given by q by p square. So, consider the example above, but now you are interested in finding the probability distribution and the number of failures predicting the first success and getting the right product. So, the probabilities are found out given the values of p and q as 0.8 and 0.2. So, this is the geometric distribution how it look like. So, a recent study indicates that Colgate toothpaste have a market share of 45% versus 55% of Pepsodent. Ms. Dabbawala, the marketing research executive firm, wants to conduct a new test for which she wants users of Colgate. Potential participants from the test are selected by random screening of users of toothpaste to find the Colgate users. So, now you want to find out that given if the probability that there are 5 users, then you want to find out that probability that 5 users will have to be interviewed. It is not 5 users, my mistake. So, they have to be interviewed. So, if the probability is to be found out, if there are 5 users, will have to be interviewed by Ms. Dabbawala to find out the first Colgate toothpaste. So, it can be the first trial, second, third, fourth and so on and so forth. So, P is given as 45, PQ is given as 55, hence the probability that x is equal to 4 we can find out from the formula as p to the power 1 and q to the power 4. In the hypergeometric distribution, so f of x is given. So, now here I would like to mention one very important thing. For in all the distributions we have considered technically the obviously which is right, the population is infinite. Here also in hypergeometric the population is infinite, but we will consider it to be such a very large value and it is denoted by capital N, because N would be coming into the calculations for the hypergeometric distribution. So, this is a unique case and remember that. So, f of x is given and you remember that here that capital N is coming into the formula. So, that will make sense in the whole calculation. So, the parameters are capital N, small n, p, expected value is given by n into p. So, this n into p and n into p for the other distribution binomial distribution would make sense. So, in the limiting case, so a variance is given by npq and in the bracket capital N minus small n divided by capital N minus 1. Now, again it will make sense because as capital N increases to infinity, this ratio of capital N minus small n by capital N minus 1 becomes 1, hence the variance also becomes equal to the binomial distribution. So, example, consider the example above. Now, we are interested in finding the probability distribution of the number of failures or success for getting the wrong or the right product when we choose n number of products, and inspection is being done for a total population of n. Consider n is very large, here it is 100. So, given that we can find out the distribution x. So, remember here the p and q values which are the actually the proportions which we can consider. If you remember in the last second class, we did mention that corresponding to relative frequency chance, it becomes actually equal to the probability in the long run as the sample size increases. So, p and q are the proportions of getting a good item and a bad item respectively. In this distribution we are considering choosing is done without replacement. If replacement is done, so obviously the formula would change. This is the hypergeometric distribution, how it looks like. Now, suppose that the automobiles arrive at this is an example, at Mr. Ghosh's garage in lots of 10, and that for a time being the resource consideration he can inspect only 5 out of these 10 for safety. The 5 cars are randomly chosen from 10 of the lot. If 2 out of 10 cars on the lot are below standard for safety, then what is the probability that at most 1 out of 5 cars is to be inspected by Mr. Ghosh will be found not meeting the safety standards. So, here capital N 10, small n 5, n into p. Now, going back to the concept of p is given. So, you multiply p into capital N to get the numbers in the values or the frequencies, and given q, capital N into q comes out to be 8, hence the required probability is given for when x is less than 1. So, that will be 0 and 1, and you find out the probabilities accordingly. Now, the Poisson distribution is given by the formula where lambda is the parameter, expected value and variance both are lambda. So, now Poisson distribution would become slowly very important. So, basically it is something to do with the discrete distribution, number of people entering the queue is or basically being served for a server, or so called people standing in front of the ticketing counter, and all these things can be cited. So, we would not go into the details of the derivations, all these things, as I said. So, we will come back to the example directly. Considering the arrival of number of customers at the bank teller counter, if you are interested in finding the probability distribution of the number of customers arriving at the counter in a specific interval of time, we know that the average number of customers is 5, and based on that you can find out the distribution, which is Poisson distribution. So, this is the Poisson distribution, how it looks like. Again, along y axis f of x is there, that is vertical one, and along the horizontal one is x. So, consider Mr. Gurnik Singh, who is the cashier at the department store cash counter, notices that the average number of customers arriving at the cash counter per 5 minutes per interval is 10. Then what is the probability that more than 5 customers arrive at the cash counter within the interval of 5 minutes. So, basically we consider lambda as given within that 5 minutes, which is 10, and proceed along with that. So, here lambda is 10, hence the required probability is given, and that can be found out very easily. Log distribution is given by this formula. This should be remembered, x's are all positive, p is the parameter, between 0 and 1 expected value and variance is given. So, we will consider examples being emission of gases from engines against fuel type, used to represent the distribution of the number of items of product purchased by a buyer in a specified period of time, and so on and so forth. So, this is the log distribution, putting some values, and so it looks similarly, the fall looks like the exponential distribution or the Poisson distribution, conceptually, like the shape wise, not the exact way, but the shape how it looks like. Now, we will consider the continuous distribution, which are very specific for our studies. There are a lot of continuous, lot of discrete distribution, but we will not consider that. So, they are the uniform distribution, the normal distribution, the exponential, the chi-square, the t, and the f distribution. So, mainly what we will consider once the normal case is over, we will consider the chi, t, and f distribution would be, which would be very important for us. So, the uniform distribution is almost similar to the discrete case, but only the values between a and b are now continuous. So, a and b are the parameters, where a and b along the real line and b is greater than a. Expected value is given as the midpoint of center of gravity, which is a plus b by 2, variance is given accordingly. So, example, choosing any number between 1 and 10, both inclusive from the real line, would give you some hint about the concept of uniform distribution. This is the uniform distribution. So, now we will consider the normal distribution with the parameters mu and sigma square. So, distribution f of x given as it looks like, and mu is along the real line and sigma square is greater than 0. Expected value is given by mu and variance is given by sigma square. So, example, consider the average age of a student between class 7 and 8 selected at random in the city of Kanpur. So, this is the normal distribution, but obviously normal distribution would be very important. So, we will discuss something more about the normal distribution as we go. Now, consider the exponential distribution, which if you see the shape of that curve would almost look exactly like the Poisson distribution, just for your interest, and obviously there is some relationship between the Poisson and the exponential. We will come to that later. So, a and theta the parameters, where a is along the real line, theta is greater than 0. Expected value is given by a plus theta, variance is given by theta square. So, it is basically to do with the light distribution and number of hours of an electric bulb till it survives. So, the exponential distribution falls exponentially, and only one thing, that value, in case if say for example the starting value is 0, so the whole distribution will shift onto the left. So, I will come to that later on, but just for interest. Mr. Bharadwaj, an electrician, knows that the time a bulb operates before it gets fused is exponential distribution with a mean lifetime of 100 hours. So, what is the probability that any bulb will work continuously for at least 200 hours? So, given theta is 100, we replace that in the formula, but only remember that finding out the CDFs now, rather than summing it up, we have to basically integrate it, because it is continuous. From that you will find out the value. So, greater than 200 would also mean the complementary part being on the left hand side, which is less than 200. So, total probability is 1 minus any of them would give you the other. Now, as I did mention 3 slides before, there is a relationship between Poisson and exponential. This is the case, and this is very important conceptually. Obviously, theoretically it is very interesting to note that, but we would not go into theory. If a process has the intervals between successive events as independent and identical, and it is exponentially distributed, the number of events in a specified time interval will be given by Poisson distribution. So, there are interval between them, the arrivals are given, then obviously the processing time would be the other distribution. So, discrete being Poisson, continuous being exponential. So, cumulative distribution, we know that is the sum of all the values starting from 0 or minus infinity to that x, and for the discrete case it is summation, for the continuous case it is basically the integration. The properties of the distribution function CDF values, it is non-decreasing. So, obviously, if x1 is less than x2 or less than equal to x2, so capital F of x1 would always be less than equal to x2, because for any incremental value from x1 to x2, the value cannot be negative, it can be either 0 or positive, because this is probability. So, if x tends to minus infinity, capital F of x, which is the CDF, is 0. If x tends to positive infinity, the f of x is 1 and f of x is right continuous. So, if you put values of do a simple transformation, put the value of z as x minus mu by sigma square, we get the standard normal, and the standard normal tables are there, we will use that accordingly. So, remember, capital F of x is equal to capital F of z, because the transformation gives you the values. Small f of x will be given by small f phi of z, which is the actually technically the PDF values, and similarly the value of capital F of z is also given by capital phi of z. So, these are very simple to understand. This is the standard normal distribution with the mean value of 0, variance is 1, and for them tables are available. Now, as it is symmetric, it is very simple to understand. Small phi of minus z will be equal to small phi of plus z, because it is symmetric. Capital of minus z would basically be the complementary part of say for example capital Z, and probabilities of A being less than x and x being less than b, you can find out using the cumulative distribution function, and when the left limit tends to minus infinity and the right limit tends to the positive infinity, in the two cases we can solve the problems accordingly. So, this is the normal distribution, these are the A and V values just for example. So, you can find out the CDF values, capital phi and all those values accordingly here. So, we will come to that later. Now, this how we will come to that later, and we have the charts here. So, the standard normal distribution is given. So, if you basically find out the first column, z values are given from 0 to 3, it can continue to infinity, but obviously the values would be very, very small. And on the topmost row, the values of z point something values are given from 0 to 0.09, and the values which are inside this sheet, all these are the so called cumulative distribution functions, CDF values starting the integration from 0 to that particular value. So, if you see the pink curve, so obviously there will be complementary part on the left hand side, you can use that accordingly. So, only one thing. So, this z distribution which is there for where standard deviation is 1. So, at plus 1 and minus 1, these are the inflection points, they can be found out very easily and you can solve the problems for many of the cases. So, consider this in an example, 20% of the students failed, that is obtain a score which is less than equal to 40, 10% of the student obtain a grade of say 70 marks or above. Assuming normal distribution of marks, find the mean and the standard deviation of the distribution and you can solve the problems accordingly. So, here steps which we will do solve the problem. Probability of x being less than 0.40 marks is equal to, for the corresponding value of z will be given, and say similarly when you want to find out the value of probability of x greater than 70, you can find out the other z. Putting those values to, there are two equations, two unknowns, mean and standard deviation, you can find them and the value comes out to be 54.12 and 17.64. So, Professor Rampal's mathematics examination, 20% of the students failed and 10% the same example, as students continued got a score of 70 and based on that we calculate the values as given. So, this is the standard normal distribution and we solve the problems accordingly. So, now few approximations are there. So, the normal approximation which will be important for the binomial distribution would be let x be equal to binomial p n n. P n n are the parameters. So, where n is large and p is small, then the distribution can be approximated with the normal with the mean equal to the binomial distribution which is n p and the variance equal to n p q. So, we can solve accordingly. So, if it is say for example, Poisson distribution, it can be converted to a using the concept to a normal distribution. If it is say for example, the exponential distribution, it can be converted to a normal distribution. But remember, the mean value and the variance of the corresponding normal distribution will be coming from where the original distribution is. So, obviously, there will be approximation, but it gives us good solution. So, De Moivre's Laplace limit theorems. So, these are very easy to understand. In case say for example, if you want to consider the binomial distribution, mean value in place of say for example, mu becomes n into p and the variance in place of sigma square or square root of sigma which is standard deviation, it becomes square root of n p q and we can solve the problems accordingly. So, these would not be actually used, but they may be interesting to discuss later on when we consider TQM2. So, in Markov's inequality, let z be a non-negative random variable such that expected value exists, then for every positive t, we will have probability of z greater than t is given by expected value of z divided by t. So, t is basically a positive integer. In the case it is a Chebyshev's equality. So, it does not mention anything about the negative or positive values of the random variable, but if its first moment and the second moment exist, then the mod of the distance between x and its mean value within a certain bound is, if given by the value of t, then there is a relationship that the mod would be the bound would be less than equal to or greater than equal to t sigma is given by inverse of 1 by t square. So, higher or lower the value of t will basically give me the answer. So, let x be the number of successes so let x be the successes of n number of trials in a monoid trial. So, each with the success p, then for arbitrary positive values of epsilon we have limiting in case it basically x is x n by n minus p being less than equal to epsilon is given by 1 as n tends to infinity. Have a good day and thank you very much.